Okay, guys, we're back with page 2 of graphing polynomial functions in your 5.3 day 1 notes. So remember, when you're graphing a polynomial, it's going to feel a little bit different than what you're used to graphing. When you graphed a straight line and a parabola, you needed exact points. You had a y-intercept, you had a slope to move to more points. When you graphed a parabola, you had your vertex, and then you either had to make a table or use 1a and 3a and 5a. When you graph a polynomial, you really only find certain exact points, but then the rest of it is going to be a sketch. Okay, so the only exact points that we're going to find are the x-intercepts. And then the other parts of the graph we're going to get by following rules and then filling in that behavior. So my graph and your graph might not look exactly the same, and that's fine. All right, so when we are graphing these polynomials, you have to know about their end behavior. What is the end behavior of a graph? It's basically what is happening at each end of the graph. So when you run out of x-intercepts, that's what we're talking about. So if you had a graph that, let's say, crossed the x-intercept at -3, 2, and let's say 5, okay? And then the graph did this. The end behavior of this graph is talking about what's happening at this end and what's happening at this end. To the right of the last x-intercept and to the left of the last x-intercept. What is the graph doing? All right, so which direction is the graph going? To the right of the last x-intercept. Well, look here. To the right of the last x-intercept, is the graph going up or down? This one's going down. That's its end behavior. That means that this end of the graph ends down. To the left, which direction is the graph going? To the left of the last x-intercept. To the left of the last x-intercept, what is this graph doing? This end of the graph is going up. That's the end behavior. To the right and to the left of the last x-intercept. All right, and then they make you write it a little bit differently. So it says, as x gets bigger, which means as x is getting bigger and bigger and bigger and bigger and bigger. So as x goes to infinity, because infinity is the largest number. As x goes to infinity, what is y doing? Well, look at this graph. As x gets bigger and bigger and bigger, what is y doing? It's getting smaller and smaller and smaller and smaller and heading to negative infinity. So they would write this as x goes to infinity, f of x, the y, because that's what we call y now, the y is going to negative infinity. It's going down, 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 down. All right, well, as x gets smaller and smaller and smaller, which means as x goes to negative infinity. So as x gets smaller and smaller and smaller and smaller and smaller, and it goes to negative infinity, what's the y value doing? Well, think about it. As these x's go, this y value, this graph is going up, 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 up. So now they would say, as x goes to negative infinity and gets smaller, f of xy is getting bigger and bigger and bigger. He's going to infinity. All right, and we'll get more used to that as we see it more, but that's what end behavior is. End behavior is what's happening at each end of the graph. Is y going up or down? Okay, all right, well, depending on what degree polynomial you are, degree 1, degree 2, degree 3, degree 4, there is certain end behavior that that graph is going to follow. So if you look at the front page of our notes, all right, a degree 1 polynomial, look how the graph went. His graph was a line, right? And this end went up, and this end went down. So it's said to have different end behavior. One end of the graph goes up and one end of the graph goes down. Look at your degree 3 polynomial graph, right? This end of the graph was going down and this end of the graph was going up. It's different. His end behavior was different. Each end went in a different direction, and this end graph goes in different directions. His end goes up and his end goes down. Look at your degree 5 polynomial graph. This end of the graph went down. This end of the graph went up. All right, each end of the graph ended in a different direction. That's how odd degree polynomials graphs is going to be. Each end of the graph goes in a different direction. One end will go up and one end will go down. But look at your even degree polynomials, your degree 2 and your degree 4. A degree 2 polynomials graph, the parabola, it either ended both up, or we had parabolas that went like this and ended down. So now its end behavior will be the same. Both ends will go up or both ends will go down. Look at your degree 4 polynomials, your m's and your w's. This end went down and this end went down. they have the same end behavior. Both ends of the graph end in the same direction, both down. And then there was this one. This end of the graph ended up, and this end of the graph ended up. That's because it's an even degree polynomial. Both ends of the graph will end in the same direction, okay? All right, so let's write those rules down because you're gonna have to memorize them to use them. So end behavior rules. If you are an odd degree polynomial, right? So if you are a degree 1, a degree 3, a degree 5, a degree 7 polynomial, this is what your graph is gonna do. Your graph is gonna end in different directions. So one end of the graph is up and one end of the graph is down. Well, then it's kind of like, well, which end of the graph is up and which end of the graph is going to be down? Well, that depends on the sign of your leading coefficient, the LC, the number in front of that term that had the highest exponent and variable. If your leading coefficient is greater than 0, which means your leading coefficient is a positive number, then your graph will be up on the right, the positive side of the graph, if you will, and it'll be down on the left, the negative side of the graph. And this will be easier when you start seeing it. All right, but what if the leading coefficient, the number in front of that term that had the highest exponent and variable, what if that leading coefficient is a number that's less than 0? So what if the leading coefficient is a negative number? If the leading coefficient is a negative number, then it's going to be up on the left, the negative side of the graph, and down on the right. Okay, and that's how odd behavior polynomials graphs are going to be. Well, if you're an even degree polynomial, let's say you're a degree 2, a degree 4, or a degree 6 polynomial, etc., well, then your end behavior has to be the same. So both ends will be up, or both ends will be down. But it has to be going in the same direction. Okay, well, which one is which? Which ones are going to go up and which ones are going to go down? Again, it depends on the sign of that leading coefficient. So if the leading coefficient is greater than 0, so if the leading coefficient is a positive number, both ends will go up in the positive direction. All right, if the leading coefficient is a number less than 0, which means the leading coefficient is a negative number, then both ends of your graph should end down. Okay, so I've written here a list of steps as to how you want to construct the graph of a polynomial function. So it's going to seem like a lot, but I'm telling you, sometimes this is nicer because you don't have to find so many exact points. Like I said earlier, the only exact points you have to put on it is going to be your x-intercepts, the points where it crosses the x-axis, and then the rest of it's just going to be a sketch based off of its end behavior, who should be up and who should be down. All right, so the first thing you want to do when you get ready to graph is find your x-intercepts or your zeros. Well, guys, how do we do that? Well, I've been saying all along, when you set an equation equal to 0 and solve, who are you finding? The x-intercepts. So you're going to set equation equal to 0 and solve. So when you set it equal to 0 and solve, well, how are you going to solve it? Hopefully you're going to be able to factor it because that's our number one way to break apart these higher degree polynomial functions. And then you're going to set each factor equal to 0 and get your x-intercepts. Okay, all right, once you find your x-intercepts, you're going to plot them on your x-axis. Now, you have to watch out for double roots, like if you got the same answer twice, like x equals 2, x equals 2. We'd learn about that way down the road, so don't worry about it right now. Just be on the lookout for the future that if something happened, if you had the same answer twice or the same answer 3 times, like x equals 3, x equals 3, x equals 3, or even if you had x equals -2, x equals -2, x equals -2, something happens on the graph, but like I said, we deal with that later. later. I'm just warning you to watch out for it later. All right, then you have to identify the degree of the polynomial and to find the sign of the leading coefficient, because the end behavior is going to be based off of the degree and the sign of the leading coefficient. So you have to identify that information. Once you identify the degree and the sign of the leading coefficient, you can determine your end behavior, whether it's both ends are up, both ends are down, or it's up on the right and down on the left. You have to determine that end behavior and mark it on your graph. All right, then you're going to sketch the graph of the polynomial by connecting the dots and creating a smooth continuous curve that has the correct end behavior. And again, in the future, we'll watch out for double and triple roots, but not yet, so don't worry. All right, and then just make a note. This will just be a sketch of the polynomial functions graph. So everybody's graphs might look a little bit different, but as long as we have the same end behavior and the same x-intercepts, we should be okay. All right, and you'll see what I mean as we start graphing them more. A more exact graph can always be found by taking a table of values and creating more exact points, meaning plug actual x values into the equation and get actual y values out. But we don't need to get such an exact graph. We're just going to get a sketch. All right, we have one more page where I'm going to do all the examples with you. So I'll be back.